Well, hello everyone. Welcome to part 3 of string graphs. This webinar is the third in the series of 4, as you have heard from Brian. And today we're going to be taking a look at where the strings in our string graphs, where they actually meet. And you've probably noticed already that some of the graphs are taking on a curved shape, even with these lines. We're going to be taking a look at solving simultaneous equations, some of the number patterns that occur within the coordinates, and the visual graphing patterns that appear when you commit these to a graphs application. My name is Roger Wander. I'm going to be taking you through this webinar today. So we'll start off with a little bit of treading backwards and just taking a look at what we've done so far. Activity 1 from this series involved stitching lines that were formed by connecting points on the y-axis and the x-axis. When they're done individually on Nspire, you get a variety of colors to appear, and we got that nice pattern that you saw within quadrant 1. Those were selected points on the coordinate axes. That was all done in activity 1. In activity 2, the guiding lines, if you will, changed. They were the x and y axes. They then became the lines with opposite gradients, and throughout most of activity 2, you were looking at the lines y equals negative x and y equals positive x. And it's really important, I think, for you also to be remembering that the selected points were actually given to you to guide you. Here's negative 10, 10 on y equals negative x. Here's point 1, 1 on y equals positive x. And those 2 points were joined, and a whole series of points were then created in that way. Now that was activity 2. In activity 2, you also needed to be working with the algebra that was involved. And as you can see on your screen, various gradients had to be calculated first, and then using the formula, m equals y2 minus y1 over x2 minus x1. And all of this was done on the calculator page of your calculator. And then the 2 versions of linear equations, one of them, the y equals m brackets x minus h plus k, was very useful for placing in the known gradient and the coordinates of one of the points that the line was going through. And in this activity, it was suggested that you use the point on y equals x, so it was 1, 1, 2, 2, 3, 3, etc. But when those are entered into Nspire, of course, another version appeared, and that was the y equals mx plus c formula, where Nspire has put the y-intercept before the linear term, and you can see the gradients appearing there. We also took a look at parameters, and that t which was assigned as the numbers 1 through 10. In activity 2 and in the webinar that we had to support activity 2, t stood for the number of the actual equation. And there were 10 equations, so there were 10 values of t. In activity 2, when you expanded that to take a look at other values of t, the curvature was quite apparent. By the time you got to the end of that document, you could see very definitely the beautiful symmetric curve that appeared. And that was all due to the guidelines y equals x and y equals negative x. Now, in the previous webinar, I didn't use the exact equations from the worksheet. I used ones that were similar. They were lines that had opposite gradients, but were slightly different from the ones that you were asked to do in the worksheet. And here were those equations, negative 1/2 x plus 1 and positive 1/2 x plus 1. In a similar way, in that previous webinar, we connected pairs of points, and you were guided as to which pairs of points they would be. For those of you who did watch that webinar, I chose, because of the nature of the equations, to choose only points that had even x coordinates so that we wouldn't be bogged down too much with fractions during the limited amount of time that we had. Okay. Now, in this webinar today, we're still going to be using those as the guidelines, but our focus is going to be on where do those lines meet. Now, you might say they meet all over the place. However, we're concentrating on where consecutive lines meet. So I'm now showing you the part 3 page, the worksheet, and a little screenshot of the top of that page, which gives you an idea of what you are asked to do in that third part of the series of string graphs exercises. We're locating points of intersection between consecutive lines. So it's very important to note that within the aims and keep that as your focus. Points of intersection are going to be asked for, and it's consecutive lines. So line 1 and line 2 is a pair of consecutive lines. Line 5 and line 6 is another pair of consecutive lines, etc. Determining the rule that connects those consecutive points of intersection is the ultimate goal of the third worksheet. And again, we explore the use of how parameters can be used to describe the patterns. Now you see that in the first part of the worksheet, and this is honing in on the first bit here, these are references to points that are on the actual worksheet. Negative 10, 10, and 1, 1. Negative 9, 9, and 2, 2. And how they were used to form equation 1 and equation 2. In our webinar today, we're going to be obviously using different points because they are from different guiding lines. But the techniques that we're going to see on Nspire will be largely the same. To give you an idea of what we actually mean by these consecutive lines, that intersection point that's being pointed out is where our first 2 lines intersect. Here's where the second 2 lines intersect, etc. So we're going to spend some time taking a look at the various algebra that can be used on Nspire to help us out with that. So let's take a look now at our calculator page. And I have started this one up because we have a limited amount of time in this webinar with putting in a reminder of the 3 lines that we came up with, the first 3 lines, which in webinar 2 we called Y1, Y2, and Y3. For those who aren't remembering from last week, or maybe you didn't see last week's video, this little C that's circled here is an indication that I have put these on the calculator page using something called Insert Comment, which can be found by pressing the menu on the calculator page, going to Actions, and then going down here to Insert a Comment. Now, I don't want to insert any other comments, but that's where I found it. And what it allows you to do is to put in some reminders along the way that are can be useful for you if you scroll back up. A word of caution to students, it is not like a word processor, and so you can't go in there and change any comments without completely copying and pasting a new one. So it does have some limitations, but it can be a very useful kind of thing, and I hope that you find that it is today. So I'm just going to clear all that out, and we're on the calculator page now. And the first thing I'm going to do is to show you a way to use the calculator to find out where line Y1 intersects with line Y2 in a way that you might have done this, or that you might be asked to do by your teacher, which is doing it completely by hand. And you can get the calculator to actually mimic that, doing the same thing to the left side as you do to the right side. You've heard that from your teachers a lot, and that's quite correct. So we're going to do that. I'm going to type in this part of the equation, and I'm going to type in this part of the equation as well. Now, if I go back up to that comment, I can actually highlight. And now I'm going to copy that and go down here and paste it. And that's Control V. And I'll set that equal to line Y2, which was Y equals, and I think what I'm going to do here is to get rid of the Y equals part of it and just set the 2 parts equal to each other, because if Y equals one of them and Y equals the other, if we want to see where the lines intersect, let's make both of them sit together. So the right side of line Y2 was the fraction, which is Control Divide, -1/6, and that gets multiplied by the brackets x minus 4 plus 3. X minus 4, close the brackets, plus 3. So that's similar to what you would write on paper. Now, when you do that and press Enter on Nspire, there is some simplifying that takes place. We see we've got this expression here, and it might be a good idea, since it actually expresses them as 2 fractions subtracted equals another 2 fractions subtracted. It might be useful here to use one of our fraction tools. You may not have seen this before. So if you go to Menu and go to Number, scroll down here to Fraction Tools, you see that we have Common Denominator. And that's also a command you can look up in the dictionary, but it's handy to see that. Common Denominator. And in there, I want to put all of the line that we have above. A very fast way to do that with Nspire, for those of you who haven't done much work with Nspire yet, is to now press the up arrow key to highlight the last expression that we had got as a result. If I now press enter, it does automatic copy and paste. And that's a very, very handy way. It saves you lots of time. So we're going to see what Nspire does with the common denominator command. I press enter, and you notice now that it's now set this out as two fractions equal to each other. Well, there are many ways that teachers use to guide students into what their next step might be. But for some of you, you may have learned that if you take the common denominator of those two fractions, which is 6, and multiply both sides of that equation, the left side, 8 minus x over 3, the right side, 22 minus x over 6. If you multiply both of those by 6 over 1, the denominators cease to exist. They cancel out, and life is a lot easier. Now, we can do that quite nicely by just pressing the multiplication key, and you notice what comes up. ANS, which stands for answer. It means it will recognize your previous answer, which is that expression that was up above, and we're going to multiply it by 6. That's the electronic version, the technology version of showing times 6 over 1 on the left side and times 6 over 1 on the right side. And when you do that, you can see Nspire has thrown brackets around that entire expression. And that's exactly what's happened. We have got rid of the fractions, which is what we wanted to do. I bet your teacher's next direction to you would be to expand the brackets. So let's do that. We can tell Nspire to do that by going up back to the menu, going down to Algebra, scroll to the right, and you can see the command expand is down there. I'll leave the path on there for you for a second. What do we want to expand? Well, we want to expand the previous answer. Remember, we get to that simply by pressing the up arrow key. That copies that expression. We press enter. That pastes it down into the brackets where we wanted it. I press enter again, and we have an expression that is much easier to solve. Now, that expression, 16 minus 2x equals 22 minus x, is now open to us to do what we would like to do, usually bringing the x's together on one side and the numbers together on the other side. If you would choose to bring your x's on the left side, which is what a lot of teachers would suggest is the good first move, we would want to add x to both sides. So I'm going to press the addition key, and it is going to add x. So our previous answer plus x. When we press enter, immediately we get that next simplification. We have got now 16 minus x equals 22. It's a little bit more simplified. We'd now like to throw 16 over on the other side by subtraction, since it's positive. But watch what happens when I press subtract. We get now answer minus. Now, what do we want to subtract from both sides? It's the number 16. Press enter, and it's greatly reduced again. You can see that just as your written working out, you knew you were on the right track. If you were gradually getting it more and more simplified, we have only one more step to perform, and that is multiplying or dividing both sides by -1. Let's divide both sides by -1 and press enter, and we've got x equals -6. Okay, well, there's our x coordinate of the first point that we have chosen to find, and that was the intersection of line 1 and line 2. I'm just going to go up and show you that and remind you that. To find out what the y-coordinate is, we want to put that into either equation 1 or equation 2 to sub it in. And so what I'm going to do is to take a complete copy of equation 1, and maybe because of the previous experience, maybe I will copy instead. I will take this version of equation 1, which is just the x part. I will press Control Copy. We'll go down here and I'll write solve, open brackets, and I can get the solve command by pressing menu in algebra as well. Y equals, and now Control Paste, solve that. And now I want to solve that given that we already have an x value. The given line, which is a vertical line, is outside the brackets. To find that, we press Control equals. And we have all of our inequation symbols, but the one that I want to grab is this one, the vertical line. That means such that, or given that. And now I want to type x equals -6, but I've already, instead of typing it, I'm just going to go up and grab it and press Enter. And when I press Enter again, what it's asking for, too few arguments. I want to solve this equation for y. So what I need to slip in here is a comma y. I want to solve it for y. Remember, the comma is down here. Okay, now when I press Enter, I've got my exact value, 14/3. Now, that's generally showing you what you might have done if you were asked by your teacher to do this completely without technology, to do it by hand. Subbing -6 back into the fraction, into one of the equations. I chose y1. And getting the fraction 14/3 as the value of y. I'm going to now show you another way to solve pairs of equations, and this time I'm going to use equation 2 and equation 3. Now equation 2 we're going to be using the solve command once again, and I will go to menu, and this time down to algebra. And you notice that's item number 1, so we have solve, and what do we want to solve? Well, we're going to put in equation 2, and we're going to put it in its full form. Y equals fraction, Control divide, -1/6 brackets x - 4 close brackets +3. So that equation, now these are simultaneous equations, so I'm now going to press the space key, which you probably don't use very much, but it's down here in the lower right of your handheld. So we press the space key once, and then we type the word and. AN is in italics, but when I press the word D, or the letter D, I get and to straighten up, and that is our indication that this is a recognized command within the calculator screen. I press the space key again, and I put in the second equation, which is actually our equation 3, y equals, and I'm going to put in the fraction, even though I know there's a simpler version of it. Control divide for the fraction. I put 0/6 multiplied by x minus 6 plus 4. And remember, at any time, as you're developing this, you can just scroll up to the top of the screen where all those equations are listed. This is very handy. Now, if you're using this command for solving the simultaneous equations, which means finding both x and y all at once, after putting in the first equation, space, and the second equation, type a comma x and a comma y. That's very important. That's the syntax that we are going to be using. When I press enter, we get x equals -2 and +4. Well, those are the coordinates of our second point of intersection. Now, back on the worksheet, I'm just going to go back to the PowerPoint and go back to the worksheet. One of the aspects of question 5 on the worksheet is to start filling in values on a table. And you can see these examples are from the actual equations that you've been dealing with in Activity 1 and Activity 2. These aren't the same ones that we just did now because they come from different guiding lines. But the onus is on you to complete this table in question 5, and there will be a lot of work for that. Now, when you are doing this for hours, and I emphasize the word hour here, for our table, we found that the equation pair 1, which was line 1 and line 2, remember equation pairs now, x coordinate -6, y coordinate 14/3, there's the point. Equation pair 2, which we just found by using that solve one equation and another equation, -2, 4 was the point. We now go back to Nspire. And see how we're going to do this with our other equations. Now, when we solve the other equations, we're going to get some similar values. I can see that we're getting close to our ending time, so I'm going to presume that by using the commands that we have here, that you are able to come up with our other equations quite handily. I'm just going to show you one thing you can do with this. It's possible to copy the entire line from up here, copy that down, and we're just going to tweak this now for equation 3 with equation 4. Now, equation 3 was the 0/6 x minus 6 plus 4. The next equation, which I didn't put down in the list up there, follows the same pattern. The numerator for the fraction is seems to be going up by 1, so the next one is a +1/6, and the points that you would be led to here in the same way, instead of x minus 6, it's x minus 8, and it's +5. We saw those patterns and we're using those again. And when we solve that equation, we can now press enter. We don't need to put the cursor at the end. We get a third point. When we go up here, copy and paste again, let's put in our equation 4, which was +1. That was 8. This one was 5. And continuing the pattern, that numerator was increasing by 1. It was 2/6. That is now x minus 10 plus 6. And when we press enter on that, we get another set of points. Now those sets of points lead us to, I'll go to the PowerPoint here, they lead us to being able to complete the table for lines 1, 2, 3, and 4. And you can see our set of points. And the big deal here now is to say, well, what's the pattern? Remember, this time T stands for the equation pair. Now, we're very close to having to finish this webinar. So I'll just go through a couple of slides here that will tell us that, well, the first job is to link up the x-coordinate. And we can see that these x-coordinates are going up by 4s. Something you'll learn in later mathematics is that if you have your values of t going up by 1, but this going up by 4, there's something in here in the definition that you will say, well, maybe the t has been multiplied by 4 and something else has happened. 4 times 1 is 4. How do we get to -6? Well, maybe we subtract 10. Does that happen here? 4 times 2 is 8. Subtract 10, you get 2. 4 times 3 is 12. Subtract 10, you get 2. 4 times 4 is 16. Subtract 2, you get 6. So it must be 4t minus 10. And it can be shown using the techniques that are described on the worksheet that the y-coordinate for these points is described by a very complicated equation. Some of you have met these before, but it's possible to get them. And the patterns that can be described then will be very useful. Now remember, these are for guidelines that are different to the guidelines that you're using in the worksheet. But hopefully they will be of some use to you to practicing before you go back and complete the worksheet successfully. We wish you the very best of luck in completing that activity, and we know that you're learning a lot of mathematics if you are doing so. Thanks very much for watching, and we'll see you next time.